descriptive statistics dealing with group data calculations. In this study at hand, we shall look at how grouped data can be used to calculate the mean, the mode, the standard deviation. So mean basically is the average. So whenever data is compiled and put into frequencies, we call it grouped data. So we have 10 to 12, 13 to 15, 16 to 18, 19 to 21, and the respective frequencies are given as follows. So what we want to is to find the mean. So for group data, mean is given by x bar is equal to summation of x over n. So we need to fill in the frequency distribution table. So we have a 4, 12, 20, and 14. So we need to find our midpoint, which is x. So to find the midpoint, we will add the lower bound and the upper bound, we divide by 2. Upper bound, we divide by 2. So how do we find the lower? How do we calculate the midpoint? So 10 plus 12 is 22 divided by 2, we get 11. 13 plus 15 is 28 divided by 2 is 14. 16 plus 18 divided by 2, we get 17. 19 plus 21 divided by 2 is 20. So this is what we call our midpoint. So far, we together? Then when we apply the frequency times the value of x, the midpoint, we get the f of x. So 4 times 11, 44. 12 times 14, 168. 20 by 17, we get 340, etc. So the total that we have is our f of x of 832. That is the sum of f of x. So when we total up the sum of the frequencies, it's called our sample size n. So when we sum up the total frequencies, we get our sample size n. So dividing f of x, by n gives us our mean. So in this case, the total here was 382 divided by 50. That is how we found our mean of 16.64. That is our average. 16.64, that is our average. Anyone behind so far? How did you find the midpoint again? Memory, how did you find the midpoint? We add the lower bound plus the upper bound divided by 2. That's how we found the midpoint. Lower bound plus upper bound divided by 2. So this is how we're finding the figures here. Then we multiply the frequency times the x, we get f of x. So the total of f of x and the total of the frequency, which is n, we get our mean, which is 16.64. The distance from here to here is called your height. So from 10 to 13, from 13 to 16, the difference is 3. So the other way of finding the midpoint is simply by adding the lower bound and upper bound, which is 11, then you keep adding a 3, 11 plus 3, 14, 14 plus 3, 17, 17 plus 3, 20. So here our height is also still 3, it's maintained. So basically this is how we find our mean or average. Okay. Can I proceed? Let's proceed. We go to calculating our median. How do we calculate the median? The median is given by the lower bound Lm plus n over 2 minus f over fm times the I, which is our height. So the first thing is we are going to reconstruct our frequency distribution table. So 1 to 10, 11 to 20. Can somebody remember how do we find our cumulative frequency in the previous class? How do we find our cumulative frequency? We add on, so 8, we add to the 14. 8 plus 14, what do we get? 32. We add the 12, what do we get? 44. We add the 9, we get what? 53. We add the 7, we get 60. So this is called the frequency. So here we get 22. Sorry, then here 34, 43, and 50. So this is how we get the cumulative frequency. So the 8 here, 8 plus 14 is 22. 22 plus 12, we get what? 34. 34 plus 9, we get 43. 43 plus 7, we get 50. So this is how our frequency distribution table looks like. Who remembers the total of the frequency is called what? What is the total of the frequency called? Samia? The total of the frequency is called N. N is 50, which is the same as the 50 here. So this is our frequency. If we wanted to find the midpoint, of course, we don't need it in this case. How do we find the midpoint? Who remembers? How do you find the midpoint? Add the lower bound plus the upper bound divided by 2. So 1 plus 10 is 11 divided by 2, 5.5. 11 plus 20 is 31. 31 divided by 2 is 15.5. 21 plus 30 is 51. 51 divided by 2, we get 25.5. 81 plus 40 is 71 divided by 2, we get 35.5. But look, it's also easy. You just add a 10 on each of these ones. If you go to 5.5, just add a 10, 15.5, add a 10, 25.5, add a 10, 5.5. So here this should be what? 45.5 if you want. That is how the midpoint is sorted out. But that's not my interest here, is how to find the median. The median is given by the lower bound. So first you start with n over 2. 50 over 2. What is 50 over 2? 25. So 25, you look for a number here between which 25 will lie. The number that first exceeds 25. So it's not 22, it's 34. So you draw a visible arrow here, 34. So 34 is here. The number above the 34 is called capital F. The lower boundary in the same line with 34 is called our LM. Now, let me pause a bit here, because this is one of the toughest when it comes to classifying in ungrouped data. So you must realize that our first class we had mentioned to say the difference between these two is that one is a histogram and one is a bar chart. Which one is a histogram and which one is a bar chart between A and B?
B.
B is a histogram and A is a bar chart. So you can also tell from the classes which one is a histogram and which one is a bar chart, depending on how the information is depicted. So here we have 1 to 5, 6 to 10, then here we have 11 to 15. We have 4, 6, 2 as a frequency. Then here we have 1 to 5, 5 to 9, 9, 13. We have frequencies 4, 6, and 2. So which one is a bar chart and which one is a histogram in terms of the classes that you are seeing here? Which one has spaces and which one is continuous? So I can call this C and I can call this D. Which one is continuous and which one is discontinuous? So D is continuous, was moving 1 to 5, from 5 to 9, from 9 to 13. Whereas A has spaces. So we have 1 to 5, there's a space of 1. 6 to 10, there's a space of 1. 11 to 15. So ideally, when you're given this format, it's easy to transform it into a histogram. But when you're given in this format, it's not easy. You need to adjust it. And the principle for adjusting this is by simply subtracting 0.5 and adding a 0.5. 0.5 is a standard figure. So in this case, instead of having 1, we subtract a 0.5, it will be 0.5. The upper bound, we add a 0.5, so this will be a 5.5. Then this is subtract a 0.5, it is 5.5. Then add a 0.5, it will be 10.5. Here subtract a 0.5, it will be 10.5. Here add a 0.5, it will be 15.5. Here, these numbers were not the same. Now they're the same. Here there's 5.5. And the other side, there's also 5.5. There's 10.5. Here there's 10.5. That is ideal for a histogram. Here there's 5 and here there's 5. Here there's 9 and here there's 9. This you don't need to adjust, it's already corrected. So when do we adjust? When you see that there's a gap remaining. So now we're able to draw a histogram for A. You cut it here because sometimes not starting from 0 exactly. So we have 0.5, 5.5, 10.5, 15.5. The frequencies we have 1, 2, 3, 4, 5, 6. So 5.5, that one we get a 4. So this 4, you put it here. 5.5 to 10.5, we have a 6. So here we take this here. 10.5 to 5.5, we have a 2. So this is how this is done. Are we following? Are we together? So similarly, to draw this other histogram here, 1, 2, 3, 4. 1, 2, 3, 4. So we have 1, 5, 9, 13. So here we have 1, 2, 3, 4, 5, 6. So from 1 to 5, it is at 4. From 5 to 9, it has 6. From 9 to 13, we have a 2. So histogram must have a title, whatever the title we have, a class title here. Okay. So this is very important to understand. So when we go back to our example here, these ones are not adjusted, so they need to adjust. Because the 10 here is not the same as the 10 there. So we need to subtract a 0.5 from there. Okay, so let me finish up on my simplified example here. So if you're given a class of 1 to 5, 9 to 5 to 9, 9 to 13. Five to 9, 9 to 13. Okay, so here we had numbers 4, 6, 2. 4, 6, and 2. So I said, how do you find the cumulative frequency? This capital F, you add on. The 4 comes here, plus 6, we get a 10, plus 2, we get a 12. This 12 is the same sum total here of 12 about n. How do we find the midpoint? We add this plus that divided by 2. So 1 plus 5 is 6 divided by 2, 3. 5 plus 9 is 14 divided by 2, 7. 9 plus 13 is 22 divided by 2 is 11. So the height is the distance from here to here, which in this case our height is 4. Our height again from here to here to here, our height is what? 4. Then you can square our x. This one is 9. This one is 49. This one is 121. Then you can find the f of x. And you can find the f of x squared. Okay. So in this case, we're going to multiply. This is a key multiplier. So this is column 1. This is column 2. So we can call this column 0, the multiplier. So to find the f of x, 4 times 3 is 12. Find the f of x squared, you start from the multiplier. 4 times 9, what we get? 30 what? 36. F of x, 6 times 7. We get 6 times 7, we get 42. Never make a mistake of squaring this to get the answer. You start from the multiplier again. 6 times 49 is 294. 2 times 11, 22. 2 times 121, 242. So total here, we use a seemingly E-looking figure, summation of x, seemingly E-looking figure, summation of x squared. So you get the totals here. So 12 plus 42 plus 22 will give you 76. 36 plus 294 plus 242 will give you 572. And our n is 12. So I want us to just find 5 things here. The mean is summation of f of x over n. So 76 divided by 12. So this is 6.333. That is how we find our mean. Our variance is given by f of x squared minus f of x to the power 2 over n, everything over n minus 1. So in this case, our f of x squared is 572. Our f of x is 76 to the power 2 over the n is 12. Everything over n minus 1, and our n in this case is 12. So that is 76 squared divided by 12. You start from this part here, because the calculator may miss you if you're going to use BODMAS. So this alone here is giving you 481.33. This alone here is giving you 11. So 472, 572 minus the answer that we found here will give you 90.667 divided by 12 minus 1, which is 11. So our variance in this case will be 8.2424. This is how we calculate our variance. This is how we find the variance. The variance is given by the symbol s squared. The formula will just establish that it is fx minus summation of f to the power 2 over n, everything over n minus 1. The standard deviation is going to square root the variance. Okay, get s. So since our answer in this case was 8.2424, when you square root this, the name changes to our standard deviation, which is 2.87 as a value. 2.87 as a value. And this is what we covered yesterday. Are we following? Mr. Samuel, are you following?
Yes, I am.
Okay. So we now go to our 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 coefficient of variation. So coefficient of variation CV is simply standard deviation divided by the mean times 100. So our standard deviation is 2.87, and our mean, we just found our mean in this case was 6.33. So our coefficient of variation can be in percentage or in decimal point if you want. So here we're going to get 45.35%. That is called our coefficient of what? Variation. That is how you compute it. So I said we need to find 5 or 6 stuff. We found our mean, found our variance, we found our standard deviation, we found our coefficient of variation. Have you been left behind on any of these before I go to our mode and our median? It's an issue of memorizing the formulas. And I proceed to the mode and the median. So mode means most frequent. Median means the middle value. So we're going to now calculate our mode. So mode is equal to what? L plus D1 over D1 plus D2. Okay, there are different formulas. This is the easiest, firstly. Once you get the concept, you'll be able to apply in what formula you have in your notes. So this is our cumulative frequency, this is our actual frequency. So you identify the highest frequency. It's called your FM. Above it, it's F1. Below it is F2. In the same line, we have our L, which is our lower bound. So some books will give you mode as Lm plus Fm minus F1 over 2Fm minus F1 minus F2 times height. To follow what I've given you there. But the easiest for undergraduates is this. So let's follow this for now. Our L is the lower bound. So we identified the highest number, that is our M, Fm. In the same line, we have our L. On top of it, we have F1, below it, F2. Or we just say our Fm is the highest value. The distance above is called D1. So from here to here, our D1 is what? Our D1 is 2. That's the distance above. From the 6 to the 2 is our distance 2. Our D2 is 4. Then our L, M is the lower boundary. The lower boundary is 5. This is the upper boundary. So what is our lower boundary? 5. What is our distance above? 2. Bring back the 2 here, 2 plus. The distance below, it is 4. And what was our height? From here to here to here to here, our height was 4. So this will give us 5 plus 2 over 6 times 4. So 2 times 4 is 8. 8 divided by 6, 1.33. So 5 plus 1.33, we get 6.33. That is how we find our mode. I repeat, the highest value here is 6. The distance above is D1. The distance below is D2. Where there's a 6, we identify the lower bound, which is our 5. So to calculate the mode, we go to the Lm, which is a 5. Distance above, 6 to 4, that is 2. 6 to 2, that is 4. So 2 plus 4. Then this is our height of 4. Don't cancel here, that's a mathematical error. So add them first, 6, when you compute them. Is that clear? Is that clear? Suppose we use the other formula. Our Lm is simply 5. So our Fm is 6 minus F1, which is 4. Already it's making our D1, we found as 2. And 2 times 6. Then our F1 is what? 4. The F2 is what? 2. And the height of what? Height is from here to here, to here to here, the height is 4. So here we're going to have 5 plus 2. This is 12 minus 8. So 12 minus 6. This is 6 here. I have the height of 4. We get back to the same answer that we found. So 1 times 4 divided by, so this one is giving us 1.33. When we add it to the 5, we get 6.33. So we're getting the same answer again. Getting the same answer again. Okay. So let's go to finding our median. Median means the middle value. So the formula for the median is given as follows. Median is equal to L plus N over 2 minus F over Fm and the height. So usually the parameters are the same. Our Fm was 6, our Lm was 5, our height was what? Our height was 4. So we need to compute this completely. So let's identify what we have. Our Fm is the highest. So you start from here. You start with the natural step, 12. The median is half. So half of 12, what we get is 6. So you go in the cumulative frequency, look for a number which is equal to 6 of S exceeds 6. You put your invisible L there. So the number above this one is called your capital F. The number next to the 10 is called your Fm, and we have the lower bound there. So people who can't master that, I just say the same parameters we had. Fm is what we need. Then next to the F1, that's where the F is. Then the lower bound is simply the same. So in this case, our lower bound was 5, our N was 12 over 2, our F1 facing the F1 is a 4 over Fm, our Fm is this 6 times 4. So here we're going to have 5, and 12 over 2 is 6, that's 4 over 6 times 4. So 6 minus 4 is 2. 2 times 4, 8. 8 over 6 is 1.33. 1.33 plus 5, our median becomes 6.33. Note that it's always supposed to be the same, but coincidentally, in this context, we have the same figure. Are we together? All right. So we can proceed if there are no questions. I'll need you to, just for those 3 things that we've done, identify the assignment question here. You just need to find 3 things: the mean, the median, the mode, standard deviation of the values that we found on top. So follow that procedure. Just do part A based on what we have done.